All right, so you can see my screen, right?
Yes, sir.
That's great. So start. So suppose you have mm, a vector. That vector we express in our familiar Cartesian coordinate system in that way: x I hat, a y j hat, and a z k hat. Right? That's the general representation of a vector in Cartesian coordinate system. So now uh, I know where ax, ay, and az are the component of that vector a in the x, y, and z axis respectively, and also ijk is basically the unit vector of towards that axis, right? Now, if I want to represent a same vector in different coordinate systems, say that polar coordinate system, cylindrical coordinate system, and spherical coordinate system, so how it will look like, that's we want to know today actually. So basically, I'm going to talk about only the polar coordinate system, and other coordinate system will be the same. But if you understand this polar coordinate system, I hope you can also represent for different coordinate system also using the same methodology. Fine. Say that in polar coordinate we use that variable is r and theta, right? So say if you draw a polar coordinate system, says suppose I will use the a with the reference of our Cartesian coordinate system, because this coordinate system is very much familiar with us. So this is my x-axis, this is my y-axis. Say if you have a point P over there, we can make the coordinate of that point P equal to xy. The similar point we can represent in polar coordinate system using r and theta. Say now if we draw a vector from that point to P, this will be my vector. In that case, I can represent this would be my vector r, and this would be that angle is theta, right? This r and theta is basically the polar variable. Now we can make some relation of from there with this Cartesian coordinate system to the polar coordinate system. Say we can represent this vector r actually in Cartesian coordinate system x equal to I hat plus y j hat, right? Using the vector triangle law. That's thing we discussed in the previous classes. And we can also find out this value of x would be equal to r cos theta and y equal to r sin theta, right? Because if you consider, so this is would be a right angle triangle where this is actually your angle theta, this will be the r magnitude, this is will be your y, this is will be your x. Then you can find out this relation x and y. Now fine, to express the vector in polar coordinate system, then I have to also know about the unit vector in polar coordinate system. In Cartesian coordinate system, we have that unit vector I hat, j hat, and k hat. I said that that could be also represented by x hat, y hat, and the z hat, right? It could be. Sometimes they will also express in that way. Using that analogy, we will express that unit vector in the polar coordinate would be r hat and theta hat. This would be that polar coordinate, the unit vector in the polar coordinate system. Now we have to find out this vector because we know the value of the magnitude of ijk, basically the unitary vector. One, we say that in the Cartesian coordinate system we define in that way. But what will be the value of this r and theta in the polar coordinate system? That we have to find out. All right. To find out that one, first I'm going to find out the direction of this unit vector. To find out the direction, can someone tell me what was the direction of I hat and the j hat in Cartesian coordinate system? Hmm? What was the direction of I hat and the j hat in Cartesian coordinate system? Hello, can you hear me, guys?
Sir, for I, it was 1 in x-axis and 0 for y and z-axis.
0. What is the direction of I hat and the j hat?
The direction of I was on the x-axis,
Mhm.
and z was on the y-axis.
Which direction it is? If you say clearly, it would be towards that direction, right?
Towards, yes, sir, towards
Yeah, it should
upper,
be, yeah, upper
and
direction.
towards positive x-axis.
Yes, exactly. That should be
Yes,
the
sir.
exact way. So that's mean I head is towards the positive x direction and j head is towards the positive y
Y
direction, right?
direction. Yes, sir.
So I can say it another way. I is towards the increasing direction of x and y is increasing direction of the y. J head is increasing direction of the y
Yes, sir.
because I is increasing toward that direction and j is increasing towards that direction, right? Using that analogy, I will say this r head would be towards that direction. R head would be toward that direction because r is increasing toward that direction, right? So that's why I will say that r head would be towards that direction. It is the increasing direction of the r. By the same way, I can say the theta head would be towards that direction because theta is increasing in counterclockwise direction. And these two are perpendicular to each other. R head and theta head would be perpendicular to each other. So that should be actually the direction of this R head and the theta head, which is actually the unit vector in polar coordinate system. That's fine. Now I'm going to find out that value of this R head and the theta head. To find out that value of R head and the theta head, we'll use the definition of that one. We define that unit vector R head actually vector R divided by vector magnitude, right? That's the definition of unit vector. You all know that one. The vector R, I find out, which is that one, with respect to the Cartesian coordinate system. I'll write x I hat plus y z hat divided by magnitude of R would be basically the R. Then I'm going to also replace the value of x and y into that equation. X actually R cos theta I hat plus y equal to R sin theta z hat divided by R, right? Then I can find out this R hat would be basically cos theta I hat plus sin theta z hat. So this is actually that R hat unit vector in polar coordinate system, right? So it's just that you can say the projection of R actually into that axis, x and y axis in the Cartesian coordinate system. All right. Now, what about the theta head? To find out the theta head, we can do it also in the two way actually. First, I will do mathematically, and second thing actually we can also find out using that component method actually. To find out that mathematically using the properties of the unit vector. Remember, when we talk about the properties of unit vector in Cartesian coordinate system, we say that I cross j would be the k, right? We write down I cross J is basically the positive K, and so on. J cross K would be the I, K cross I would be the J, since it's a counterclockwise direction. Using that one, we can also represent this R head, theta head into also one more K head, because R and theta is basically in the XY plane. If you think about in three-dimensional in Cartesian coordinate system, R and theta would be in the same plane. Remember, for this polar coordinate system, then there will be one more coordinate which is towards the z direction. That will be the K head, right? We can write in that way actually. Then using that one, we can say theta head would be basically K cross R. Can I write down? Theta would be basically K cross R, counterclockwise direction. So definitely it
Yes,
will be that
sir.
theta. And I'll write down this thing. I'll write down K cross R head. I find out the value of theta head. Sorry, R head, which is actually cos theta I head plus sine theta z head. I have to use a parenthesis over here. Then I'm going to take the cross product of this one. I'll write cos theta is a scalar quantity. And then I'll write down k cross I over here plus sine theta k cross j. Right? I cannot shift that position. I cannot write over here I cross k. That's really the difference. I'll come to that one, which is basically the properties of uh, the vector in the multiplication. Now look at this. What it will give me? What is the value of k cross I?
Sir, K cross. Sir, it's minus. No, it's R.
No, no, no. From the this is right now actually the Cartesian coordinate system.
Oh, then J.
Yes, k cross I is going to be the plus j, right?
Yes, sir.
So it would be k cross I is over here. You can write k cross I is going to be that plus z. What about k cross j? K cross j is this one. This is a clockwise direction, right? It would be
Sir,
that minus
minus I.
minus I. Then I can write down this theta head will be basically minus sine theta I head plus cos theta z head. So that would be basically the unit vector of this theta head in polar coordinate system. You can do it another way actually, say component method. So how say if I draw you for that one, you can also do it. Say this is actually your vector. This is actually your R head, and so this is actually your theta head, right? So this is actually R head, this is actually theta head, this is the vector R, this is x-axis, this is y-axis, and create the angle over here. Now what I can do, I can shift this theta head, sorry, I can shift this theta head from here to here without changing the magnitude and the direction. I can do that one, right? So I can shift it over here. If I do that, then I can also extend this one, this negative x-axis. If I do that, then I know this angle is 90 degree, right?
Yes, sir.
This angle is theta. This angle is 90 degree minus theta.
Minus
Then,
theta.
then definitely is going to be the theta.
Yes, sir.
And this is going to be 90 degree minus theta. Right. Now I know how to take the component. I can write this one is taking that with that positive y-axis is create an angle. So that's why I look at this. I write down cos theta z hat, and it is 90 degree minus theta. It would be cos of 90 degree minus theta would be sine theta I hat, because it's towards the negative x-axis. So that's why it becomes minus sine theta I hat. Then I will find out this, or you can think about it there. Say if this is my uh, minus sine theta I hat vector, this is my cos theta z hat vector, and resultant would be that vector which is theta hat. Again, using the vector triangle law. So that should be basically the theta hat. That's how actually we can find out. We can find out using that component method, or we can also find out using that using the unitary vector properties. That's how we can find out the unit vector in polar coordinate system. Do you understand? Do you have any question over here?
No, sir.
All right. Now, if I write down a vector in the polar coordinate system, how I write? Because in the Cartesian coordinate system, I write, say, x I hat plus ay z hat plus az k hat. Then, in the polar coordinate system, I can write that vector would be ar theta hat plus a theta hat. In the two-dimensional case, I write down that vector actually in polar coordinate system, where a are actually known as the component of vector a towards that direction is called the radial component. This known as actually that radial component because it belongs towards the radius, and this one is called the angular component. Angular component, where an r head and the theta head is basically the unit vector towards in that direction. So that's how actually we can represent a vector in polar coordinate system. By the same analogy, you can also represent this vector in that, excuse me, cylindrical and also spherical coordinate system. You have to also over there you have to find out that vector first, then unit vector and the properties of that unit vector. Then you can also find out what would be the representation of this vector in that coordinate system. There's the same procedure we can follow for other coordinate systems, but you have to find out for unit vector also that coordinate system. All right. So now I'm going to ask you a question. So suppose you have a vector in your Cartesian coordinate system. If you transfer that vector from Cartesian coordinate to polar coordinate system, will the vector look like same?
No, sir.
Mm-hmm.
Sir, in Cartesian coordinate system, we have x-axis and y-axis, but in
Mm-hmm.
polar coordinate system, we have r, which is radius, and theta is we use theta for angle. So I don't think it will look same.
Same in what sense?
Mm, um, graphically,
Graphically means, say, suppose I'm going to say another way. Say you have a stick in Cartesian coordinate system, you place it towards some direction in Cartesian coordinate system. Now, it has some location or it has some position in the Cartesian coordinate system, right?
yes, sir.
Now, if you look that stick from polar coordinate system, will it be look like same or it will be in different orientation? or different direction.
Sir, I'm not sure how it
You're
will work.
not sure.
Yes,
Yeah,
sir.
yeah.
Because
Thank you
sir,
very much.
I can transfer from using XY to R theta, but I
Mhm.
haven't seen it graphically, so I can actually say that.
That's thing you should learn actually. Yeah, that's thing we are learning. That's why we are learning this very good.
Yes,
And this
sir.
is very interesting coordinates transformation. You will learn this thing coordinates transformation probably in your Math 120 course, and this is very important for you guys from computer science department,
Sir,
especially.
I'm doing Math 120 in this semester.
Yeah, then you know how they're doing that actual coordinate transformation. Why you are doing
But
that coordinate transformation?
but sir, they haven't learned taught that us yet. We are just learning basic of integrations now.
Yeah, so you will learn. So that's why I say that.
Yes,
Then
sir.
ask them why we were actually learning this. What is the purpose of learning this coordinate transformation?
Okay, sir.
What is going to do for you? You should ask definitely.
Okay, sir. I will ask.
Yeah. So what would be the application of that thing? So application of that thing basically, suppose if you are in a space, you're observing a object from one axis. If a person from different axis observe that object, it could be look like in different orientation.
স্যার if we think from our physics ওই যে পদার্থবিজ্ঞানের আধুনিক একটা চ্যাপ্টার ছিল ওইখান
Mhm.
থেকে যেটা পড়ছিলাম যে একটা পার্সন যেটা দেখবে অপোজিট পার্সন আলাদা দেখবে ফ্রম অ্যানাদার
Exactly.
অ্যাক্সিস
Exactly. Exactly.
বিকজ স্যার এভরি পার্সনের পার্সপেক্টিভে প্রত্যেকটা জিনিস চেঞ্জ হয়
Yeah,
সরি স্যার
definitely. So that's why you can say that this vector is going to be the different. If you transfer a vector from Cartesian coordinate system to the polar coordinate system or any other coordinate system, vector is going to be totally changed. Its orientation would be different direction.
ইয়েস
But
স্যার
what would be the same? Your
দ্য
length
ম্যাগনিটিউড
magnitude would be the same because
ইয়েস
that's a
স্যার
scalar quantity. It will be the
ইয়েস
remain
স্যার
same in every coordinate system.
ইয়েস
Did
স্যার
you see the movie The Gravity?
ইয়েস স্যার আই স
And
দ্য মুভি
yeah, or Interstellar. You should
ইয়েস
go
স্যার
through these things. This is the application of that thing actually. Different dimension or different axis has a different representation. The vector will be the remain same. Sorry, the scalar length magnitude will be the remain
magnitude
same,
will be the same.
but the vector could be the different because over here you have a different angle. If you change the angle of a vector, so vector direction will be the change. As a result, the vector will be the different. We can say, but the magnitude will be the remain same. It's a scalar quantity. It
Yes,
doesn't depend
sir.
on anything.
Yes, sir.
All right, so let's talk about that. Something else. I should talk about that multiplication. Multiplication of vectors. There are two ways we can do that multiplication, right? Once we define actually that dot product, or we say that scalar product, or sometimes we say that is also known as the inner product. We use that keyword in the case of quantum mechanics actually. In quantum mechanics language, we define the dot product is the inner product. And second one, we say that the cross product or a vector product, or we can also say that this is actually the outer product. Right, these are the two uh, multiplication of the vector. First one, we're going to talk about, say that the dot product. Dot product could be done in the two way. Say you have the two vector. Say I represent x I head plus ay z head plus az k hat, and the second vector say that bx I hat plus by z hat plus bz k hat. Now dot product of this vector I can write a dot b, which I can write. What I'm going to write actually, I'm going to multiply this ax I hat with the rest of the quantity of the vector or the rest of the component of the vector. Then ax bx I dot I will be 1, ax by I dot z will be 0, ax bz I dot k will be 0. So that's mean the similar identities I dot I, z dot j, and the k dot k will be survive, but the dissimilar identity will be vanish. So from that we can write it would be ax bx plus ay by plus az bz, right? If you do that step by step, you will find out. I'm not going to do that one. I hope you can do that one using the unit vector properties of Cartesian coordinate system. Second method, we can write a dot b is ab cosine theta, right? So where theta is the angle between that vector a and b. Say this is actually your vector a, this is the vector b, and say this is the angle is theta. Then you can use that one. So if you just know the vector, then you can use that one to find the dot product of these two vector. And if you know the angle between them, then you can use that one. So that's the way actually to find out the dot product of the two vector. And is a scalar quantity. We know that it has no direction, it has only the magnitude. So that's why we can say that a dot b could be greater than 0, it could be equal to the 0, and it could be also the less than 0. It could be greater than 0 if theta is, say that, greater than 0 but less than 90. Then the magnitude of the dot product of two vector would be basically positive, which is greater than 0. It would be equal to 0 if theta is 90, right? Pi by 2. And it could be less than 0 if theta is greater than 90 but less than 3 pi by 2. So that's mean if you find some value, using that value actually you can say that actually the why it is positive, why is negative, and which direction it is actually. So that should be the case to find out that dot product of two vector. And dot product, since it's a scalar quantity, it doesn't care about if I write, say that a dot b equal to that b dot a, it will be the remain same. Like if you say 5.6, whatever it is, if you say that 6.5 is going to be the same, right?
Yes, sir.
Now let's talk about actually that vector product. Vector product. There are two way also over here. First one you can use, say that determinant process I, j, and k. So I'm going to write the coefficient of vector, which is actually that ax, ay, and az, and coefficient of b actually that, or the component of the b, bx, by, and the bz. Right now, what I can write from there, I can write that procedure. I hope you all of you know that. Uh, but the problem is, you guys make a mistake to doing that calculation actually over here. Don't do that. If you do that, definitely you are going to lose some mark in the exam, because you are learning this formula from your school life. It wouldn't be fair to make a mistake from this thing. So what will be the case? To write down the I, I'll write down AY BZ minus AZ BY. I'll write in the plus over here. There is the issue I'll talk about when I'm writing the plus over here. In that case, it would be AZ BX minus AX BZ plus K head. It would be AX BY minus AY BX. Sometime you will find out the minus some of your book or your reference book, then this thing is going to the reverse. If you use the minus sign over here, it would be ax bz minus az bx, right? But I use that plus sign. Why I use the plus sign? Actually, uh, I didn't memorize this formula, or I'm not going to recommend you to memorize this thing. If you do that, then definitely you are going to make a mistake. What I did, I use a technique to carry this information in my head. I write down in that way, say x, y, and z component in that way. Suppose if I want to find out that x component, which is basically the I component, right? Then I'll write down the y component of the first vector into z component of the second vector. In that way, ay bz minus az by. It's a back and forth relation actually, because I know that from counterclockwise is positive and the clockwise is the negative, so that's why it's a minus sign over here. So that's why when I write down the a component, I write down the ay bz minus az by. For the y component, when I'm going to write down the y component, so that's mean the j component, I'll write az bx minus ax bz. It's a back and forth relation actually. I'm saying again, for the z component, you will write ax by minus ay bx, right? It's very simple actually if you carry this information in that way. When you're going to x component, you have to take the product of the other two actually, but follow that instruction actually. If you move from counterclockwise direction, it will be positive. If you move to the clockwise direction, it will be the negative. Then you will find out this formula. And I carry this information in my head in that way. So I hope there will be no scope to make a mistake of this sign convention over here. All right, the second method, which is we write a cross b, actually ab sine theta into eta head, right? So this is actually your second method. If you know the angle between the two vectors, then you can find out this cross product of these two vectors over here. But I said what would be the direction of this eta head? Eta head must be perpendicular on both a and b. So suppose if you draw two vectors in that way, so this is the vector a and this is the vector b, then the eta head would be either toward that direction, which is perpendicular on both a and b, or it could be towards downward direction. In that case, if you say this is on the positive eta head, then downward would be negative eta head actually. And if you take the a cross b, that would be actually towards the positive direction eta head. But if you write down the b cross a, it would be towards the downward direction. So that means towards the negative eta head direction. And that convention we can find out using the right hand rule. Are you familiar with that right hand rule?
Yes, sir.
That's great. So what that rule actually, to find out the direction, you have to place your index finger towards the first vector.
Yes, sir.
And your palm towards the second vector. Then if you rotate rest of the finger from first vector towards the second vector,
Will
then
be the
your
direction.
then thumb will give you the
Thumb.
direction
Yes,
of
sir.
your resultant vector. So that's how if you place your forefinger or the index finger, say that toward that direction, and this is, say this is your palm, which is towards the second vector, and say this is actually your thumb. Then if you rotate that finger from here to here, then thumb would be basically towards upward direction. So that's why the eta head would be upward direction. But if you consider this is your first vector, then your hand place will be look like that. This is your index finger towards the first vector, and this is your palm towards the second vector. Then if you rotate your finger from here to here, then actually your theta would be, sorry, I keep it in that way, it would be downward direction actually. That's wrong. So this is the case. This is actually your index finger. This would be your palm. Then definitely if you rotate from here to here, your thumb will be the downward direction. So that's how actually you can find out the direction of this theta head. Remember, this theta head will be always perpendicular on both A and B. It doesn't require that A, B are perpendicular. Sometimes it could be, sometimes not. But this theta head must be perpendicular on both A and B separately. And this cross product is antisymmetric. He said that A cross B is not equal to that B cross A. Basically, why? Because it changes direction. You can write down this one only if A cross B equal to minus
B cross
B
A.
cross A. Then it will be equal, otherwise not. He said that cross product actually the anti-symmetric. It's not symmetric, but the dot product is symmetric. So that's why we say that A dot B would be basically to B dot A. We can write in that way. Now, what is the physical significance of this cross product? Or why we are doing this actually, the dot product and the cross product? Say, you have a room. Think about of your room. I draw the 3-dimension. Say this is actually your floor of your room. So if you indicate one length by a vector, say that A, another length is vector by the B, and say another length is C, which is the upward direction, 3 vector. Now can you tell me, if you take that cross product of any 2 vector or any 2 length of your room, what it will give you of your room? Did you get my question?
Yes, sir.
You get that one? My question is, if you have a room, in your room you indicate 3 side by 3 vector. Now if you take the cross product any 2 vector of your room, what it will give you of your room? That's my question.
Sir, length, height. No. Sir, if I place something in my room, I can identify its direction and its position in my room using coordinates or this A cross B directions.
Only no, sir. All right, so I'm going to ask in another way. Says, can someone tell me whether the area is a vector or a scalar? Is the area is a vector or a scalar?
Area is a vector quantity
Area is a vector quantity. That's
with a
good.
both direction and
So
method.
what will be the direction of the area?
The length and the breadth.
Length and breadth is the direction.
No, it's like no.
Sir,
Your
that
answer is right.
theta
Area is a vector.
A cross B, we do A cross B,
Yes,
AB sine theta and eta. Then eta will be the direction.
It will.
exactly. Area is a vector, right?
Yes,
So
sir.
when you learn this formula area, you write down the formula in that way: length cross breadth. You never seen that length dot breadth. Did you ever seen that they written that formula in a instead of
No,
cross
sir.
symbol use the dot because
No,
they
sir.
it is a vector. So that's why they use a cross formula over here. Although the magnitude will be given the same, right?
Yes,
5 into
sir.
2. If you write 5 cross 2 or 5.2 is the quantity is the same. Say sorry 10, right? But the formula they retain because it's a vector, and the direction of this vector will be always perpendicular that surface, right? I said that A cross B, eta head will be always perpendicular on both A and B. So that's why when you multiply by this one side with the other side of your room, A cross B, that's give you the area of your room. And the direction of this area would be either this direction perpendicular to that surface. If you consider this is your surface, it will be perpendicular to that direction, upward direction or the downward direction. That would be the case actually to find out that direction of that area. And remember, this is a area is a that's why is a vector, and the direction would be the difference. So if you take that A cross B, it will be upward, but if you take the B cross A, it will be the downward direction, right?
Yes, sir.
Now, can you tell me if I write say that A cross B dot C, what it will give me of the same room? What I will find out. Physically, what I will find out
The volume.
is the volume, and the volume is a scalar quantity, right?
Yes, sir.
It
Yes,
has no
sir.
direction
Yes,
because
sir.
if you multiply that equation, also telling me it's a scalar quantity because this is the area. With that area, if I multiply one length, that will give me basically that volume, and volume is scalar quantity since it's a dot product. A cross B, if you write down to one vector, say that D dot C is a scalar quantity, scalar product. So that's why 1 minute, guys. Sorry. All right. So that's why if you write, say that A cross B dot C, that will give me the volume of your room. Now, can you tell me what would be this one? B cross C dot A
Sir, it's also volume.
is also volume, right?
Yes, sir.
So then, or I can write, say that uh, C cross A dot B, right?
Yes, sir.
It would be all are equal.
Yes, sir.
So, or you can write A cross B into C. It will be the same because it's representing the same thing, the volume of your room. That's why you can write down. It doesn't care about if I write down the B cross C with the A or C cross A dot B, all would be the same because it's a scalar quantity. Since the volume of your room is the same, whatever the case, you first take the length into breadth or into height, or height into length into breadth is going to be this. It's not going to make any difference. It's going to be the same thing because it's a scalar quantity. What about, say, can I write, say that A cross B cross C will be equal to, say that C cross A cross B will be same? It's not going to be the same because it's a vector
No,
product.
sir. Directions will be different.
Different. So
Yes, sir.
that's why we cannot write down, say, this thing actually. And there's a rule, it's called actually the backup rule. We use that idea. If you extend your idea, then you can use that one, but it's not going to be the, basically it's called the triple product of this vector. Whether it's a scalar or the vector, it's going to be the same. We can write in another way. In this case, say that if you write A cross B cross C, it's also that one, but we represent it that way. It's a B A dot C is a vector minus C into A dot B. We write down in that form is called actually that backup rule. Look at this. If I write that letter BAC and this is CAB, we use that backup rule for the vector triple product. So otherwise, this formula is too tough to memorize. So we use in that technique actually to carry this formula in our head. It's called the backup rule. We can also extend this idea for, say, that more than three or the four vector using the same way. Say if I write A cross B cross C cross D, we can also use that formula. How we will use? First, say I will replace this A cross B by a new vector E, then C cross D. Now I can apply the backup rule over here, right? So what would be that? Is too tough. If I write, look at this, C into E cross D minus, it would be, or there is another way I use that formula actually. You say if I label it in that way, 1, 2, 3, it's a 2, 1, 3, and this is a 3, 1, 2. Like now I am going to replace that number 1, 2, 3. This is actually, look at this, is a 2, 1, 3. Now I'll write down 3, 1, 2. So 3 is basically the D into E cross uh, E cross 2 is C, equals C actually. That's why actually we can extend this idea for more than 2 or 3 vector. But they will not give you this more than 3 vector actually. Up to that level is enough for you actually, not more than 2. But that's the technique actually. You can extend your idea of more than 2 or the 3 vector. All right, say uh, let's do a problem. Say I have, so this is, can you tell me what would be the angle uh, between the two diagonal face of a cube? Did you get my question?
Yes, sir.
What would be the angle? So this is your room,
Sir, they are parallel to each other.
parallel, is it?
Sir, can you say the question again?
So what is the angle between the face diagonal of a cube?
Face diagonal. Oh no. So 90 degree.
Hmm. All right, let's check that. This is the case, right? So this is one face. Say this is a one wall. So you are standing over here. So this is one diagonal of this face, and this is another face or the wall. You can say that, and this is the diagonal of that face or the wall. Now my question is, what is the angle of these two diagonal face?
Sir, it's 90 degree.
It's 90 degrees. Say it loudly. Don't worry.
Yes, sir.
It's 90 degree. All right. Let's check that. At least you are talking. That's great. You're trying. So I'm leveling this axis so that it would be easier for you. Say this is my x-axis, this is my y-axis, and say this is my z-axis. Say for simplicity, basically, I label all the cube length is basically the one. Say unitary, I'm considering. Say this unit is one, this unit is one, and this is unit will be one. Or you can use any number because it's a cube. All the length are equal, right?
Yes, sir.
All right. Say for simplicity, I'm taking this as one unit. Say I'm label that vector. So this is the vector A, and this is the vector B. Now, what will be the coordinate of that point? Can anyone tell me? What could be the coordinate of that point? Say all the unit of this one, say the one. This unit is one, this unit is one, and z axis is also the one. Then what is the coordinate of that point? Hmm?
Sir, it will be I, Z, and K simply.
No,
One,
that's the
one.
unit vector.
So 1
Ah,
comma 1.
one. No, no. So that point, it would be 0, 1, and 1. Am I right?
Sir, it's 0 because in x-axis. Oh, yes, sir. Because it's not in the x-axis. It's only in YZ plane.
Exactly.
Yes,
So what
sir.
about this point?
Sir, it will be 1, comma 0, comma 1.
Exactly. That's great. Point. Now I'm going to express that vector. Look at this. I can write this vector. A is uh, I hat plus 0 plus k hat into 1 other, right? But I neglect that
Yes,
one
sir.
actually. Then I can say that vector A is I hat plus k hat. By the same analogy, I can write down the vector B would be j hat plus k hat, right? Am I right?
Yes, sir.
That's great. So now I'm going to use that formula to find out that angle. A dot B would be AB cosine theta. Remember, always use that formula to find out the angle between any two vectors. Never use A cross B. Sometimes A cross B you give you the wrong answer actually. Because if you cannot find out the direction properly, then it's very tough to find out that using that formula. Sometimes that work, but sometimes it's not going to the work unless you cannot find out the direction properly. So that's why it is safe to use that formula A dot B actually a b cosine theta. This formula is always going to the work if you just know the angle between the two vectors. All right, so I can find out that magnitude of vector A is root 2 and magnitude of B is also the root 2, right? 1 square plus 1
Yes,
square is
sir.
going to the root 2. Now what about A dot B? I'm going to take that dot product. I dot J is 0. I dot K is 0, right? Or you can write them side by side. Then it will be easier for you, I hope. I dot K dot into dot
So it will be 1.
z dot k. It will be 1.
Yes, sir.
That's great. Yeah. I dot j is basically, then should I draw do that one, or I can write down directly 1? It will be 1. You can do by yourself. I hope you can do that. Use the properties of the unit vector. You will find out it will be
Yes,
1.
sir.
I dot j is 0, I dot k is 0, k dot z is 0, but k dot k is basically the 1. So you'll find out the 1. Now find out that angle is going to be cos theta would be a dot b divided by magnitude of a and magnitude of the b, which is actually will be that root 2 into root 2 is going to be the 2, right? A dot b
Y-
basically the 1,
yes, sir.
and this root 2 and root 2 is going to be basically the 2. Then what will be the theta? Cos inverse half.
60 degree.
Yeah, this angle is 60 degree.
Okay.
So now if you draw a diagonal one of your wall and another wall which is connected to that wall, if you draw another angle into that another diagonal into that wall, now the angle between these two diagonal faces is 60
60
degree,
degree.
is not 90 degree.
Okay, sir.
That's how actually you can use this dot product to find out that angle. All right, next, this is another problem. It is also interesting case actually. So a plane is basically landing. When it's landing, these are the four forces actually acting on that. Now I want to find out the resultant force on that plane when it is basically the landing. So landing is basically the descending its height, right? Right.
Yes, sir.
That's great. Fine. Now, can you predict without just calculation? Just can you predict? I'm not saying that you are going to answer this one, but just can you make a guess? So, what could be the resultant direction of the force? Just the direction, not the magnitude. I'm asking just only the direction. When he's descending that plane for his, I should say, the safe landing, what could be the resultant direction of the force on this plane when it is landing? Or I can say in term of your axis, you have the four coordinate, right? First quadrant, second quadrant, third quadrant, the fourth quadrant. What, in which quadrant it would be for safe landing of the plane, of this plane?
Sir, fourth quadrant.
Fourth quadrant. Any other guess? Hello? Hello, can you hear me?
Yes, sir.
Yes, sir.
Probably, I think my system is hang. It's not. It's working.
Or, sir, it might be in the first quadrant.
You change your
Sir,
idea.
I'm not sure because F1 and F4, these two have the same value. So
Mm-hmm.
these two are neutral. So if
Mm-hmm.
I see F3 and F2, F2 is 1.1 to the power 3 Newton and F3 is 5, but it has another. I don't
Right.
know.
Now look at this one. Use your real idea. Say if you say in the first quadrant in the resultant vector. So I'm explaining your answer. Look at this. If you say the resultant force in the first quadrant, right?
Oh, sir,
So
might be in fourth quadrant.
it might be different.
I guess it's in the fourth quadrant.
So what about others idea? There are two votes for this fourth quadrant, one vote for that first quadrant. What about the other idea? But though, what about other guys? You are thinking that the plane is not going to the land. If you are keep quiet, I will assume that one. You are thinking that the plane is not going to the land. Someone say the second quadrant, someone say the third quadrant, then all the option is going to the cover. Yeah, let's check that actually. So if you say in the third quadrant, then say probably that direction. Because remember, when it's landing this plane, actually, basically, there are two forces acting on that plane, right? One is basically vertically downward, which is actually the gravitational force is sucking that plane towards its ground. This force is acting directly in the downward direction, and another force actually on the plane, which has moving towards the forward direction. That was actually provided
Yes,
by the
sir.
engine of the plane, right? So that's mean the resultant force would be over here in the first quadrant.
Okay.
So, but if it is in the first quadrant, then it might be a cause actually if your runway is not going to provide that amount of force in the opposite direction, then it will be harder for the plane to make a safe landing, right?
Yes, sir.
Yes, sir.
So so that's why when a plane is going to the landing, actually, it must be ensure that your surface is going to give you enough frictional force on that plane so that the plane can make a safe landing on that runway. So it cannot be in the fourth quadrant actually over here. So that's why it is the
Okay.
wrong. In the first quadrant, it cannot be also the same. In that case, the gravitational force will be towards in the upward direction if the resultant force in that direction. Because one force
Oh,
is towards the
yeah.
forward direction. If it's in
And
the far coordinates, then definitely other component should be in the y direction.
yes,
Then the
sir.
resultant force will be in the first quadrant. Otherwise, it's not possible. It cannot be also in the second quadrant because plane applying a force towards in the forward direction,
Yes, sir.
right? So that's how actually you can make a guess actually for
But,
this case. Yeah.
sir, in third quadrant, the x-axis will also be negative. It's
Yes.
not going
This
in
is
the
this is the
forward. It's
force.
going.
This is the force. This is right. So provided by the gravity.
Yes, sir.
This is also right. That is also going to provide. It must be greater than your forward force.
Oh, yes, sir. Now I get it.
Your frictional
Yes.
force, the
Yes,
provided
sir.
by the surface, must be greater than your
Must be
forward
greater.
force by the plane. Then
Yes,
it
sir.
can make a safe landing.
Safe
Otherwise,
landing.
plane will be skied from the runway.
Yes,
Yes,
sir.
sir.
Now
That's
I
why
understand it.
your resultant force must be in the third quadrant for a make safe landing.
Yes, sir.
It has to be. This is the application of the breakthrough, guys. You know all of these things, but unfortunately, we cannot apply this thing or we cannot explain in that way in our real life case. So that's why it's a meaningless for us. This science, it's totally the garbage. We are learning this thing, but we cannot apply this thing in our real life, which is unfair. Which is, it's not your fault, guys. I'm saying that it's fault of, it's my fault. It's our fault actually, I should say, because we are not guided our student in that way. So what is the application? Why we are using this thing? Why we are learning this thing? What would be the purpose of this thing to learn? then it will be interesting, and then people will be focused on learning this thing. Otherwise, not. Unless you cannot show that, so why they should learn or why they will apply in this thing in your real life, then why they will learn this thing? It's totally useless. They will. It's like a toilet paper actually, or tissue paper. You will use one time, then you will throw into your dustbin. All right, so we can find out. Do I have time? I have 5 minutes time. All right, so I can find out this thing. Look at this. I'm going to take the component of this thing. So I'll split that vector first. Say I can represent that vector f1. So f1 is, I'll write down the minus f1 into j hat, right? If I write down that Cartesian coordinate
Yes,
system.
sir. Yes, sir.
So this is my I hat and this is my j hat. And your f2, I'll write minus f2 I hat,
I hate.
right? Now I have to split only the vector f3. F3 I can write f3 cos 45 into I hat minus f3 sine 45 j hat. Can I write that one? Because look at this, your f3 is basically over here, and I extend that part actually. That angle is 45,
Yes, sir.
and
That is
definitely also
clockwise,
45.
so we are using minus
Yeah,
or sign. Yes, sir.
this is will be x component and this will be the y component.
Yes,
That's
sir.
why I use in that way. Fine. By the same analogy, we can write then f4 would be minus f4 cos 60 I hat plus f4 sine 60 j hat, right? Because if you extend that part over here, this is 30, this is will be also the 30, but this angle would be 60 degree over here with the x-axis, right? And it's create the
Yes,
negative
sir.
x-axis, so that's why I write down the f4 minus cos 60, but this one would be that sine 60. I write in that way, or you can write down the cos 30. This will be the same, the y component. And I know the value f1, f2, f3, f4, which they given over here, the magnitude, right?
Yes,
Yes,
sir.
sir.
Then if I plug in this value over here, say that resultant force, I say that fr, it will be sum of this vector f1 plus f2 plus f3 plus f4. And if you plug in all the value into that equation, you will find out that fr, the resultant. I just jump one line, you guys can do by yourself. Just plug in the value
Yes,
of that
sir.
one, you will find out this would be 1.65 into 10 to the power 3 I hat minus 6.21 into 10 to the power 2 j hat. Two component are negative. It means that the resultant vector, it must be in the third quadrant, because your x component is
Y
negative,
component both are negative.
y component is also negative. So definitely the resultant force would be in third quadrant. You'll find out that angle basically over here. That's how actually you can find out this vector. All right, that's great. That's enough for this one actually. I have two more problem actually, but I'm not going to get the time to do that. What can I do? I can actually then make that video, and then I will upload it if I get the time actually. If I get the time, I will make the video and I'll upload
Or,
into the.
sir, you can provide us the questions. We can solve them
Yes,
in
sir. That
Slack.
would be helpful.
That can be done actually.
Yes,
You
sir.
can.
Or we can ask you if we can solve it.
All right, you can do that actually. I will post it that probably into the Slack.
Okay, sir.
Okay, sir.
Thank you.
Thank you.
Sir, should I stay?
Yes, you should stay.